Welcome back to this session. Today in this session, we'll be solving numerical based on the concept that we have covered in yesterday's session. So let us get going with the first numerical. A square bar, 400 mm square, 2 meter long, elongates 1 mm under an axial load of 40 kilonewton. Modulus of rigidity is 80 GPa. Find bulk modulus and Poisson's ratio. So what is given? A square bar is given. The area of the square bar is given equal to 400 mm. Area A is given and length. The length of the square bar is given equal to 2 meter long. It is 2 meter long. Now, when an axial load is being applied, it is elongating. The length is पहले लेंथ उसका 2 मीटर था और वहां पर लोड 40 किलो न्यूटन डालने के बाद वो इलोंगेट हो रहा है, मतलब उसका लेंथ इंक्रीज हो रहा है. कितने से इंक्रीज हो रहा है? पहले इतना था तो लोड लगाने के बाद इट इज इंक्रीजिंग 1 mm मोर वो इंक्रीज हो रहा है. तो कौन से लोड लग रहे हैं यहाँ पर? टेंसाइल फोर्स लग रहे हैं यहाँ पर. ओके, और वहां पर मॉडुलस ऑफ रिजिडिटी दिया है 80 GPa. Then we need to convert this modulus of rigidity, its unit which is given in GPa to Newton per mm square. तो कैसे करेंगे? It will be 80 into 10 raised to power 3 Newton per mm square. Then we have to find bulk modulus. What is the symbol of bulk modulus? The symbol for bulk modulus is K. Now to find this K, we need to use the relationship between modulus of elasticity E and bulk modulus K. We need to find K by using the relationship between E and K. Okay, and then we need to find Poisson's ratio. So first, we need to have E, Young's modulus E, right? Modulus of elasticity. So that is not given. So let us first find E. Now, how do we find E? We can find E many ways, right? Young's modulus E is equal to stress by strain, right? Stress by strain. We can find it from there also. Stress is equal to force by area and strain is equal to change in its length by original length. We can use that formula to find E as well. Otherwise, in this question, the value of E is found by using this relation. Elongation del L is equal to PL by AE. Okay, we can find E by using stress by strain. We can find E, and in this question they have used E. We have found E by using the relationship del L equals to PL by AE. Okay, now, so when you use del L equals to PL by AE, we will put all the values that is given in the question. So let us see. Del L क्या है? Del L is the elongation, right? कितना elongate हुआ है? तो question पे कितना दिया है elongation? 1 mm दिया है. तो हमारा del L हुआ 1. और P कितना दिया है? Load, tensile load कितना दिया है? 40 kilonewton दिया है. अब ये 40 किलो न्यूटन को हमें न्यूटन पे कन्वर्ट करना पड़ेगा. सो हाउ डू वी डू इट? 40 into 10 raised to power 3 Newton. Okay, and how much is L? L given here is 2 meter long. Now it is given in meter. We need to convert meter to mm. So when you convert meter to mm, you multiply the value with 1000, right? 2 into 10 raised to power 3 mm. So we have 2 into 10 raised to power 3 mm. Okay, divided by area. Area of the square bar is given equal to 400 mm square. So we have area is equal to 400 into we do not know the value of E. तो हमें E का वैल्यू फाइंड करना है, तो E यहाँ पर वैसे ही रखेंगे. Now अगर आप ये सॉल्व करते हो तो if you cross multiply it, ये क्या होगा? यहाँ पर क्रॉस मल्टीप्लाई करने से 40 into 10 raised to power 3 into 2 into 10 raised to power 3 यहाँ पर ही रहेंगे, और ये 40 into 400 into E इधर into 1 के साथ यहाँ पर चला जाएंगे. So E will be equal to 40 into 10 raised to power 3 into 2 into 10 raised to power 3 divided by 400. Okay, so let us see how much we get. So it will be coming 40 into 10 raised to power 3 into 2 into 10 raised to power 3 divided by 400. So you're getting 200 into 10 raised to power 3. So this is the value of E. Now by using the relationship between modulus of rigidity and Young's modulus, the relationship between the two of them is given by E equals to 2G 1 plus mu. We know the value of E, we know the value of G, and from this relation we can find the value of mu, which is Poisson's ratio. Okay, so E from the given E that we have found is equal to 2 into 10 raised to power 5 equals to 2 into G is equals to 80 GPa. So converting 80 GPa to Newton per mm square, we get 80 into 10 raised to power 3, bracket close, then bracket open, 1 plus mu. So we have this one. You can send this value 1 plus mu and get this value, which is E, to the left hand side. So as you do that, this whole value, जो आपका ये लेफ्ट हैंड साइड का वैल्यू है वो आप राइट हैंड साइड पे लेके जाते हो और ये 1 प्लस म्यू को लेफ्ट हैंड साइड पे लेके जाते हो, देन द वैल्यू विल बी इन दिस मैनर. Okay, so 1 plus mu will be equal to 2 into 10 raised to power 3 E divided by 2G. So 2G will be equal to 2 into 80 will be 160 into 10 raised to power 3. So if we do, let me do one by one. 2 into 10 raised to power 5 divided by 160 into 10 raised to power 3. So this will give you equal to 5 by 4, which is equal to 1.25. So here 1 plus mu will be equal to 1.25. Now if you want to find only the value of mu, you keep mu here and send 1 to the left hand side direction. So it will be minus 1.25. We have found 1.25 here. So if we send this 1 to the right hand side direction, it will be coming minus. So 1.25 minus 1. So minus 1 will give you 0.25. So the value of mu is coming equal to 0.25. Okay, now we have found the value of mu. Now what we have to find next? Bulk modulus. Bulk modulus is signified with the symbol K. Now we need to know the relationship between bulk modulus and Young's modulus. So what is the relationship between bulk modulus and Young's modulus? It is E equals to 3K 1 minus 2 mu. So we have E equals to 3K 1 minus 2 mu. We know the value of E is equal to 2 into 10 raised to power 5 equals to, we don't know K. K here we need to find because K here is bulk modulus. So we keep it as it is. 1 minus 2 into mu, value of mu we found it equal to 0.25. So into 0.25. So we have, let us solve the one from inside first. Let us solve 2 mu first. So 2 into mu will give you 0.5. So 1 minus 0.5 will be equal to 0.5. So inside the bracket we have 0.5, right? So 0.5 into 3. 0.5 into 3 will give you 1.5 K. So we have 2 into 10 raised to power 5 equals to 1.5 k, right? Now यहाँ से हमें सिर्फ we need to find the value of k. तो क्या k क्या होगा? K will be equal to 2 into 10 raised to power 5 divided by 1.5. So this is the value of k. Okay, so if you do this, it is coming 133.33 into 10 raised to power 3 Newton per mm square. Now if you make it 1.33 as in this question here, 1.33, it will be, the decimal point will shift 2 places in front and it will be 1.33 into 10 raised to power 5 Newton per mm square. So we have found the value of k and we have found the value of mu. We are asked to find bulk modulus k and Poisson's ratio mu. So we have found mu is equal to 0.25 and bulk modulus k is equal to 1.33 into 10 raised to power 5 Newton per mm square. So I hope this numerical is clear. Let us solve the second numerical. Now in second numerical, let me read its statement. A circular rod of 100 mm diameter and 600 mm long is subjected to a tensile load of 900 kilonewton. Determine modulus of rigidity and bulk modulus if Poisson's ratio is 0.30. If modulus of elasticity is 210 kilonewton per mm square, find linear strain. तो अभी यहाँ पर क्या दिया है? In this question, a circular rod is given. Let this be a circular rod, and उसका diameter जो है, the diameter of the circular rod given in the question is 100 mm. And what is its length? ये पूरा length is equal to 600 mm long, and it is subjected to tensile load. So tensile load मतलब it is stretching. It is stretching the circular rod, and the load that is acting is equal to 900 kilonewton. Okay. Now from here we need to determine modulus of rigidity. How do we find modulus of rigidity? We find it from the relationship between modulus of elasticity E and modulus of rigidity G. We need to use that relation to find the value of G. Okay, and then next we are asked to find bulk modulus. Bulk modulus is signified with symbol K. We will use the relationship between modulus of elasticity and bulk modulus. Okay, so here, so given here is diameter is given equals to 100 mm, length is given 600, and the force P is given 900 kilonewton. Now we need to convert this kilonewton to Newton. How do we convert? Into 10 raised to power 3. और mu का वैल्यू दिया है, E का वैल्यू दिया है, E का वैल्यू किलोन्यूटन पे दिया है, तो फिर we need to convert this kilonewton to Newton. It will be equal to 210 into 10 raised to power 3 Newton per mm square. Okay. Now we need to find G. What is G? G is modulus of rigidity. K is bulk modulus. So we need to find G and K. Now first let us find see here the relationship modulus of rigidity. The relationship is E equals to 2G bracket open 1 plus mu, right? We know the value of E. We don't know the value of G, and we know the value of mu, which is Poisson's ratio. So let us put all the values here. E is given equal to 210 kilonewton per mm square. So 210, we convert it into Newton. We get 210 into 10 raised to power 3 Newton per mm square. So we put this value here. 210 into 10 raised to power 3 Newton per mm square equals to. Now यहाँ से हमें G का वैल्यू फाइंड करना है, तो G को वैसे ही छोड़ दो. Equals to 1 plus 0.3. म्यू का वैल्यू 0.3 दिया है, तो पहले हम ये ब्रैकेट के अंदर का सॉल्व करेंगे. 1 plus 0.3 is equals to 1.3, right? So we have 1.3 into 2. So we get 2.6 G. So here we get 2 point, पहले ब्रैकेट के अंदर का सॉल्व किया और ब्रैकेट के अंदर सॉल्व करने के बाद into 2 किया. So g को g वैसे ही रहेंगे, तो we have 2.6 g. Okay. Now यहाँ से we can find g का value easily. So from here g will be equal to 210 into 10 raised to power 3 divided by 2.6. So you will getting equal to, we have 80.769 into 10 raised to power 3 Newton per mm square. So we got the value of g. Next we are asked to find bulk modulus k. So to find bulk modulus k, we need to use the relationship between modulus of elasticity and bulk modulus k. So what is the relationship? The relationship between the two of them is E equals to 3k 1 minus 2 mu. We know the value of E, which is equals to 210 into 10 raised to power 3 equals to 3k. K का value नहीं पता तो keep it as it is. Mu का value we know 1 minus 2 into 0.3. So let us first solve inside the bracket. 2 mu, which is 2 into 0.3 will be equal to 0.6. So we have 2 mu is equals to 0.6. 1 minus 2 mu is equal to 0.4. So inside we have 0.4. So 0.4 into 3 kiya to 0.4 into 3 kiya to it is coming equal to 1.2 और k को वैसे ही छोड़ना है. So we have 1.2 k here, right? तो यहाँ से भी फिर आसानी से हमें k का वैल्यू मिल जाएगा. कितना होगा k का वैल्यू? k का वैल्यू will be equal to 210 into 10 raised to power 3 divided by 1.2. So this is coming equal to 175 into 10 raised to power 3 Newton per mm square. So this is the value of k, which is bulk modulus. Now last, they've asked us to find linear strain. What is linear strain? Linear strain is signified by a symbol E. Linear strain कहाँ पर आते हैं? अभी ये circular rod हुआ, यहाँ पर force लग रहा है ऐसे और उसका length increase हो रहा है. क्यों increase होगा? Because the force that is acting on this circular rod is a tensile force. राइट. सो जब टेंसाइल फोर्स लगते हैं उसका लेंथ इंक्रीज हो जाते हैं और उसका डायमीटर डिक्रीज हो जाते हैं. ये डायमीटर इज द सेकेंडरी डायमेंशन, राइट. तो ये डायमीटर जब हम यहाँ पर स्ट्रेन फाइंड करते हैं उसको हम लेटरल स्ट्रेन बोलते हैं. जब उसके ओरिजिनल लेंथ के हमें स्ट्रेन फाइंड करते हैं उसको हम लीनियर स्ट्रेन बोलते हैं. सो द लीनियर स्ट्रेन हियर विल बी इक्वल टू E equals to change in its length by its original length L. So how much is its change in length? So change in length is not given. Del L is not given, and L, the length of this circular rod, is given equal to 600 mm. Now by using the relation E here is the linear strain equals to del L by L, right? So del L is equal to PL by AE, right? PL by AE. और यो जो L है डिनोमिनेटर पे, यो हम डिनोमिनेटर पे छोड़ देंगे तो कितना होगा? into 1 by L. नहीं तो PL by AE into L, right? So we cancel L, ये L और ये ऊपर का न्यूमरेटर का L cancel किया तो we will only have P by AE. We have only P by AE here, right? So now we put all the values in here. P कितना है? P is given equal to 900 kilonewton. So converting this kilonewton into Newton, we get 900 into 10 raised to power 3 Newton divided by area. To find the area of this circular rod, diameter is given. So we'll have pi by 4 d square. D is equals to 100 square into E. E here is given equal to 210 kilonewton per mm square. So 210 into 10 raised to power 3 Newton per mm square. So solving this, we will get the linear strain. So let us solve. 900 into 10 raised to power 3 divided by pi by 4 into its diameter into Young's modulus E. So this is coming equal to 5.45 into 10 raised to power minus 4. और strain का unit नहीं होते हैं. Strain is unitless. So we have only 5.45 into 10 raised to power minus 4. I hope this numerical is also clear. Let us go to the next numerical. So here, this is the third numerical. A bar of 30 mm diameter is subjected to a pull of 60 kilonewton. It is a bar again. Diameter is given 30 mm and it is subjected to a pull. Again, it is pull. So it is again a tensile force, right? So pull of 60 kilonewton. The measured extension on gauge length of 200 mm is 0.09 mm. So now the length of this bar is given equal to 200 mm and because of the force जो pull लग रहा है वो pull की वजह से जो extend हो रहा है length पे that extension is given equal to 0.09 mm and the change in the diameter is 0.0039 mm. जब हमारा length increase होते हैं diameter decrease होगा तो decrease in diameter is given equal to 0.0039. Okay, calculate the values of modulus of elasticity and modulus of rigidity. Modulus of elasticity E and modulus of rigidity G हमें find करना है. तो let us first see what is given. Diameter दिया है 30 mm, pull दिया है 60 kilonewton. Kilonewton को newton पे convert किया तो it will be into 10 raised to power 3. Length दिया है 200 mm और जब 60 kilonewton load लगते हैं उसकी वजह से इंक्रीज हुआ है लेंथ पे और कितना हुआ है 0.09 mm और डायमीटर पे भी चेंजेस आया है कितना आया है 0.0039 mm आया है. नाउ यहाँ से हमें E and G फाइंड करना है तो we can find E with the help of its definition. Young's modulus is the ratio of stress by strain, right? तो यहाँ पर उसका डेफिनेशन के हिसाब से हमने फाइंड किया तो E is equals to stress by strain. अब स्ट्रेस फाइंड करने के लिए व्हाट इज द फॉर्मूला? स्ट्रेस फाइंड करने के लिए फॉर्मूला इज P by A. अब P कितना दिया है क्वेश्चन पे? पुल P इज गिवन 60 किलोन्यूटन. तो न्यूटन का वैल्यू जो न्यूटन पे कन्वर्ट किया है वो वाला यूज किया तो इट विल बी 60 into 10 raised to power 3 divided by its area is pi by 4 d square. D given in the question is 30. So 30 square. So let us first find the stress. 60 into 10 raised to power 3 divided by pi by 4 into its diameter square. So this is coming equal to 84.88 Newton per mm square. तो stress आ रहा है 84.88 Newton per mm square. Now strain E find करने के लिए हम कैसे find करेंगे? Strain E is equals to change in its length by original length. Change in its length कितना है? आया है change in its length is 0.09 और उसका original length कितना है? 200 mm. So 0.09 यहाँ पर 0.09 divided by 200 किया तो let us see 0.09 divided by 200 is coming equal to 4.5 into 10 raised to power minus 4. So we have 4.5 into 10 raised to power minus 4 and strain is unitless. So now हमें we have found stress और linear strain E भी हमें मिला है. So now we can find modulus of elasticity E. E will be equal to stress by strain. Stress कितना है 84.88, strain 4.5 into 10 raised power minus 4. तो हम E find करेंगे. E stress is 84.88 divided by its strain. So it is coming 188.62. यहाँ पर 186 दिखाया है. I'm getting exactly 188.62 into 10 raised to power 3 Newton per mm square. Okay, so there is a slight changes in its value. यहाँ पर 186 दिखा रहा है, जब हम calculate कर रहे हैं तो 188 आ रहा है. So there is a slight change in its value. Next, we have to find modulus of elasticity. हमें मिल गया है. Now modulus of rigidity find करना है. Modulus of rigidity हम कैसे find करते हैं? Modulus of rigidity find करने के लिए we use the relationship between modulus of elasticity and a modulus of rigidity. So relationship से यहाँ से देखो, ये relationship is equals to E equals to 2G1 plus mu. अभी mu का value question पे दिया नहीं है. The value of mu is not given in the question. So how do you find the value of mu? Mu is Poisson's ratio is equal to lateral strain by linear strain. तो linear strain तो हमें मिला है, which is E equals to 4.5 into 10 raised power minus 4. Now lateral strain. How do you find lateral strain? Lateral strain find करने के लिए उस पे changes in diameter दिखाया है, right? कितना दिया है? Changes in diameter is given 0.0039, right? Divided by its original diameter was 30. So mu is equals to lateral strain by linear strain. Lateral strain आएंगे, आपके lateral strain आएंगे del D by D. Del D कितना दिया है? 0.0039 divided by diameter is given 30. तो ये आपका lateral strain हुआ. और linear strain हमें मिल गया है पहले से ही from here, right? So lateral strain, let us see. Poisson's ratio is equals to lateral strain. Lateral strain is equals to change in its diameter, जो कि क्वेश्चन पे दिया है 0039 divided by its original diameter divided by linear strain. Linear strain we found 4.5 into 10 raised to power minus 4. So this is coming equal to 0.288. So approximately इसको round off किया तो 0.29 आएंगे. So we have the value of mu equals to 0.29 here, right? So using this value of mu here, we can get the value of G. E का value हमें पता है 188.622 into 10 raised power 3 equals to G हमें find करना है, तो it will be 2G as it is. Bracket open, 1 plus mu का value is 0.29. So let us first solve inside the bracket. 1 plus 0.29 will be equal to 1.29, right? Bracket, inside the bracket it is solved. Now into 2. Into 2 करने से we get 2.58. G will remain as it is, so 2.58 G. Now यहाँ से G का value find किया तो it will be 188.622 into 10 raised to power 3 divided by 2.58. So here you're getting 73.10 into 10 raised power 3. और यहाँ पर 72.33 दिखा रहे हैं, but when we calculated the value of E, we were getting 188 and not 186. Okay, so here again here they have taken value of E equals to 186, but I have taken 188 as we have found it in the calculator. So our value of G is coming equal to 73.109 into 10 raised to power 3 Newton per mm square. So I hope this numerical is clear. Now let us solve the last numerical for today. A metal rod 20 mm diameter and 2 meter long, when subjected to a tensile force of 60 kN, shows an elongation of 2 mm and reduction in diameter 0.006 mm. Calculate the modulus of elasticity and modulus of rigidity. अब यहाँ पर एक metal rod दिया है और उसका diameter दिया है 20 mm और उसका length दिया है 2 meter long. एंड उस पर टेंसाइल फोर्स लग रहा है और उसका इंटेंसिटी, टेंसाइल फोर्स का इंटेंसिटी इज इक्वल टू 60 किलो न्यूटन. और जब टेंसाइल फोर्स लग रहा है वो रॉड पे, तो उस पे लेंथ पे चेंजेस आ रहा है, लेंथ इंक्रीज हो रहा है. और कितने से इंक्रीज हो रहा है? 2 mm से इंक्रीज हो रहा है. और जब लेंथ इंक्रीज होते हैं उसका डायमीटर डिक्रीज हुआ है, एंड डिक्रीज इन डायमीटर इज इक्वल टू 0.006 mm. ओके, अब यहाँ से हमें मॉडुलस ऑफ इलास्टिसिटी एंड मॉडुलस ऑफ रिजिडिटी फाइंड करना है. जैसे हमने मॉडुलस ऑफ इलास्टिसिटी पिछले के क्वेश्चन पे फाइंड किया था, वैसे ही वी कैन फाइंड इट हियर बाय यूजिंग द रिलेशनशिप बिटवीन यंग्स मॉडुलस, stress and strain, right? Young's modulus E is equals to stress by strain. From there also we can find the value of E. If not, we can use this relationship here, which is elongation relationship, del L equals to PL by AE. We know the value of del L, we know the value of P, we know the value of L, we know the value of A, and we can find the value of E from here, right? So if I want to find E, I'll take E to the left hand side here. So further this equation will be equal to PL by A into del L. This del L will go into denominator here. Okay, so del L. So we have PL by A into del L. So what is P? P given in the question is 60 kilonewton. So we convert it into Newton. So we'll have 60 into 10 raised to power 3 Newton into what is the value of L? Length of this metal rod, it is given 2 meter long. Now we need to convert this meter to mm. As we convert meter to mm, we multiply it with 10 raised to power 3. So we have 2 into, instead of here there is a mistake here, instead of 10 raised to power 5 it should be 2 into 10 raised to power 3 divided by area into change in length is given equal to 2 mm. So it is already in mm, so we don't need to convert its units, so it will be into 2. Let us find 60 into 10 raised to power 3 into 2 into 10 raised to power 3 divided by area 5 by 4 into diameter is given 20 square into its elongation is 2. So we're getting 190.9 into 10 raised to power 3. Now if we move this decimal point in front, it will be 1.9. We'll convert this 9 to 1 here. So it will be 1.91 into 10 raised to power 5. So we have 1.91 into 10 raised to power 5 Newton per mm square. Okay. Now we have found the value of modulus of elasticity. Modulus of elasticity का हमें value मिल गया है. Now हम modulus of rigidity find करेंगे, तो we need to use the relationship between modulus of elasticity E and modulus of rigidity G. उन दोनों का बीच में रिलेशन क्या है? The relation is given by the equation E equals to 2G 1 plus mu. अब हमें यहाँ पर E का वैल्यू पता है, G का वैल्यू हमें फाइंड करना है, mu का वैल्यू नहीं पता. What is mu here? It is Poisson's ratio. तो Poisson's ratio फाइंड करने के लिए, what is Poisson's ratio? Poisson's ratio is the ratio between lateral strain by linear strain. right? So lateral strain क्या है? Change in its diameter by original diameter. Linear strain क्या है? Change in length by original length. Diameter पे changes कितना दिया है? यहाँ पर 0.006 दिया है. So we have 0.006 divided by original diameter 20 दिया है. So divided by 20 divided by, अब यहाँ पर linear strain is change in length by original length. Change in length कितना दिया है? 2 mm दिया है. So we have 2 divided by उसका original length 2 meter long है. So mm पे convert किया तो it will be 2 into 10 raised to power 3. So let us find mu. Change del D is equal to 0.006 and its original diameter is 20. ये हुआ हमारा lateral strain. अब linear strain is change in its length. Length पे change कितना दिया है? 2 mm और original length 2 meter था. तो मीटर को mm पे convert किया तो 2 into 10 raised to power 3 हो जाएगा. So यहाँ से हमें Poisson's ratio मिल रहा है 0.3. So Poisson's ratio यहाँ पर 0.3 मिला है. Okay. Now हमें वो सब वैल्यू यहाँ पर डालेंगे तो we'll get the value of G. G क्या है? Modulus of rigidity. E कितना मिला है? 1.91 into 10 raised to power 5 equals to 2G. G का वैल्यू फाइंड करना है तो वैसे ही छोड़ दो. 1 plus mu. Mu is given equal. Mu we have found equal to 0.3. So we have 0.3 here. So 1 plus 0.3 plus 1 will give you 1.3. So we have 1.3 into 2. 1.3 into 2 kiya to you will get 2.6. So now we have 1.91 into 10 raised to power 5 equals to 2.6 G यहाँ पर. So now we find G. G will be equal to 1.91 into 10 raised to power 5 divided by 2.6. So this is coming equal to 73.46 into 10 raised to power 3. अब यहाँ पर एक डेसिमल आगे दिया है तो हम ये डेसिमल आगे शिफ्ट करेंगे तो इट विल बी 7.3 और ये 10 raised to power 3 भी एक डेसिमल आगे शिफ्ट हो गया तो इंक्रीज हो जाएगा. सो इट विल बी 7.346 into 10 raised to power 4 न्यूटन पर mm स्क्वायर. सो हमें ये फोर्थ क्वेश्चन पे भी Young's modulus E फाइंड करने के लिए बोला था. We found it and modulus of rigidity G also we found it. So I hope this numerical is also clear. We'll solve more numerical in tomorrow's session. See you tomorrow.